So in this problem, given a Ka, we have an initial molarity, and notice that this one now gives percent ionization. That's that same word we used before to figure out the X value. So we're just going to use it right here. It actually is, I don't know, I think it's even easier than figuring out the pH to figure out the percent ionization myself. So all of this should look familiar. Again, you're probably sick and tired of seeing this one ice chart after seeing it used as an example 5 bajillion times, right? So we know that the Ka is equal to, it's x times x, so it's x squared, over 0.25 minus x. We're going to throw out that x, remember? And so that gives us, it's that same 5 number, 5.0 times 10 to the minus 6th equals x squared over 0.25. And this is actually the math that was worked out. I'm just showing you again. So x squared, it's right there. That is this number times this number is that 1.25 times 10 to the minus 6th. And then here is the square root of it. And so you get that number right there. So that's what x is, 0.001118. Once you do that, you should always double check that it's okay to do that assumption. So we're going to just take x and put it over the 25 to make sure that it's less than that number. So that divided by 0.25 times 100. Yeah, that's less than 5% for sure. That's like a factor of 10 difference. Totally okay to do this. So what I also actually just did was this, 0.00118 over 0.25 times 100%. I was making sure it's less than 5%, right? I also figured out the percent ionization. It's just asking how much ionized. Well, X is how much ionized. See, X is how much is ionized. So what I actually also solved, even though you've already seen me trying to figure out, is it less than 5%? I solved for the percent ionization. So the percent ionization is 0.45%. Easy peasy, you can do that part. Less math than taking the negative log.